Hi everyone, today we're going to dive into a fun and educational activity in creating the model of a lava lamp. This is to display some important scientific concepts we have been learning throughout the weeks. We'll look at fluid dynamics, density, and how combining materials can result in mixtures or completely new substances. This is in order to emphasise the importance of teaching practice and facilitating learning in science, to develop students' skills in the area of knowledge, working scientifically, and design and production. The proposed assessment tasks students in groups of 4 to build a model of a lava lamp to demonstrate the properties and uses of materials, focusing on states of matter, mixtures, and chemical reactions. Students will record the process using an iPad and create a video presentation that explains how the lava lamp works and the scientific principles behind it. It is developed for Stage 3 students focusing on the material world as it pertains to mixtures. However, before students can engage successfully, the proposed unit of work showcase focuses on building students' understanding of the properties and use of materials. Each week, students gain a deeper understanding of core concepts that help develop their understanding of the material world. For example, in week 1, students will be introduced to the states of matter, solids, liquids, and gases. By week 6, they explore the basic chemical reaction and their effects on materials. Each week aims at building students' conceptual understanding of scientific concepts so they integrate these learnt skills and knowledge with purpose in future learning. Now back to the assessment. The summative assessment criteria, students will be assessed based on 4 sets of criteria. Number 1, student understanding of scientific concepts, i.e. the accurate explanation of the properties of the materials, i.e. solids, liquids, and gases, and how they relate to the functioning of the lava lamp. Students will also need to show a clear understanding of mixtures, density, and chemical reactions. Number 2, quality of the lava lamp. Successfully creating a lava lamp model. Number 3, collaborative practice. Display effective teamwork through the task, equal participation of each member with each group member fulfilling their role. Number 4, visual presentation. Organise presentation of the process of building/constructing the model of the lava lamp, use of visual and audio elements to explain scientific concepts, and the use of creativity. The 5-minute video is to be submitted to Google Classroom with an individual reflection of the task to be submitted by each group member. This relates to developing a student's skills relating to producing and implementing as students make the model accurately and measure and mix materials safely. Now looking at collaborative practice. Students will work in groups of 4 when investigating, building, and completing the model. Each student has a specific role in the implementation that they are responsible for. This links to working scientifically as students need to manage investigations effectively, both individually, i.e. conducting their role appropriately, and in groups, to ensure that tasks are effectively coordinated and managed. This also shows an integration into general capabilities of personal and social capability skills, as students need to work with peers to build their lava lamp model and document the use of materials. Following on talking about the general capabilities, there are several integrated throughout the lava lamp activity. Students are encouraged to think critically about their prior learning of mixtures and how that pertains to designing and testing their lava lamp. Ethical understanding is considered when discussing the safe use of materials and accuracy of the results of the mixture of materials to create the model. And as discussed previously, students' personal and social capability is built through peer group work and collaborative practice, where they each have responsible roles that are integral in completing the task. ICT capabilities developed within the planning, designing, and documenting of the lava lamp model. The use of an iPad helps students document their progress for ease of reflection that they can refer to and allows them to develop their presentation skills. But first we'll need to review our safety measures. A comprehensive risk assessment was done prior to students completing the activity. This ensures any parameters surrounding safety are appropriately looked after and students are able to accurately and appropriately conduct their model of their lava lamp. Students during the planning and predicting stage in week 8 of the unit of work explore the importance of safety and develop an acrostic poem depicting the parameters of safe practice. This provides connection with the KLA of English and builds on students' skills relating to ethical understanding, as they are able to acknowledge the importance of conducting safe practices within the classroom. Now let's get to the science, shall we? But first we'll need to gather our materials. In gathering our materials, we'll need oil, a measuring jug, water, bicarb soda, measuring cups or spoons for accuracy, food colouring for some fun, a recyclable bottle. Remember, we're thinking about sustainability here, and vinegar. Students' critical and creative thinking is developed as students when they're obtaining their materials and conducting. Now, step 1, we need our recyclable bottle, which needs to be empty. We're going to fill the 600ml bottle about a quarter of the way full, as we can see on our measuring jug, 450 mils. Now we're going to fill the rest of the bottle with water. Notice the water begins to sink to the bottom and the oil stays at the top. As we learn in week 3, water is denser than oil. We can see clear layers between the water and oil begin to form. In fluid dynamics, denser fluid, i.e. the water, sinks below the less dense one, oil. Here we see how combining materials can result in a mixture, where each substance, the water and the oil, retains its own properties. To add a little bit of colour, we're going to go with red. Adding approximately 10 drops to the bottle, we can see that the food colouring sinks down to the water layer at the bottom. It moves through the oil and mixes with the water at the bottom. This is because food colouring is water-based and it shares the same properties as water. Now this may take some time, so in the meantime we're going to measure our bicarb soda. We can see the food colouring begin to mix with the water at the bottom of the bottle. Now in step 4 we're going to add our bicarb soda to the bottle. Carefully using our funnel, we'll need to carefully pour the bicarb into our bottle. The bicarb creates bubbles that move through the oil and mimic our lava. Step 5, moving on to the exciting stuff. Like we explore in week 6, we are going to be creating a chemical reaction by adding vinegar to our bottle. The combination of bicarb soda and vinegar creating a new substance, carbon dioxide gas. The vinegar will react with the baking soda or bicarb soda. Watch as the bubbles of gas rise through the oil carrying some coloured water with them. This happens because gas is less dense than both water and oil, causing it to move upwards. When the bubbles reach the top, they pop and the water sinks back down, creating a lava lamp effect. So let's recap what we have observed and what's happening here. The lava lamp is a great model for demonstrating fluid dynamics, density, and the result of combining materials. The vinegar and the bicarb soda react to form carbon dioxide gas, a new substance. These bubbles rise because they are less dense than the water and oil, carrying coloured water with them. As the bubbles pop, the dense water sinks back down, creating the continuous cycle that mimics the movement in a real lava lamp. This links to the syllabus for Stage 3 students, as it focuses on the effects of combining materials to produce mixtures and new substances, all within the context of making a homemade lava lamp. Learning never stops, so to further extend the task and develop students' skills towards working scientifically, they could make predictions about the effects of heat, i.e. a flashlight, could have on the properties and behaviours of the materials, i.e. the lava lamp.